Today we're going to talk about angles and radians. An angle, we learned in geometry, is made up of two rays that have a common endpoint, which is called a vertex. So one of the rays we will call the initial side, and the other one is the terminal or ending side. When we graph in standard position, the initial side will be the positive x-axis, and then we will go with a given number of degrees to graph the terminal side. So when we graph 210 degrees, we begin by graphing an xy axis. The first side, positive x-axis. And then I want you to doodle on the edge of your paper circles. Many doesn't matter how big, but just doodle a few circles in the margin of your paper. How many of you, when doodling circles, draw them in a counterclockwise direction? So it would be this.
Whoa. Wait, what?
How many of you doodle your circles in a counterclockwise direction? When you draw a circle, you draw them counterclockwise. It is a majority of people, and it doesn't even seem to be a right-handed, left-handed thing. It just seems that most people draw circles in a counterclockwise direction. When we graph angles, we will all graph in a counterclockwise direction. So it is helpful for those of you that are in the majority to remember. So if I want to go 210 degrees in a counterclockwise direction, I want to pay attention to my quadrant lines. How large is each quadrant going to be in degrees? 90. So I'll have 90 up top, 180 halfway around, 270 3/4 of the way around, and 360 around for a full circle. So if I want to go 210 degrees in a counterclockwise direction, I'm going to pass by that 180 by how much? 30 degrees. When you graph an angle, there are a few things that are required. You need both sides of that angle. You need the arrow that shows what direction you drew the angle in, and you need that value that tells us how big that angle is supposed to be according to the closest x-axis. We always want to put that value close to the x-axis. Some students may want to say that 210 is 60 short of the 270, which is correct, but not helpful for where we are going. Always put that value next to the x-axis. You don't need a protractor or measure these perfectly. We'll just put that value in there to show that we intended it to be 30 degrees there. For the next one, we're graphing negative 45. What do you think we do differently for graphing a negative angle? We go in the opposite direction, so we're going to go clockwise. We still begin in the same location, but I'm going to go in a clockwise direction, 45 degrees.
It doesn't matter which side you put it on if it's 45.
We still always want to put it next to the x-axis, even though it's the same either way.
If you do that, do you have to put the negative sign? Or does
You do not need to put negative 45. You can just put 45, the actual size of the angle. You do not need to write the degree symbol. For 510.
45 and negative 45? Or it's, never mind. I got it, because we're drawing that.
For 510, we have more than one full circle, right? How big is a full circle? 360. So what I'm going to do is still begin in the same place, and I'm going to go around 360 degrees with a spiral. And then how do I figure out how much more I need to do? Subtract. 510 minus 360 leaves 150 degrees. So where will that end?
The third second left.
In the middle of 180.
After the seventh.
30 degrees before the 180. So we always want to enclose our angle value with the closest x-axis. So it'll be 30 degrees before the 180. Always begin at the positive x-axis, go around counterclockwise for a positive angle, clockwise for a negative angle, and if you go more than one circle, draw a spiral to show how you really went. Questions? graph the next three. For negative 1, words, likewise, which would put me about here, 60 degrees before the 180. So please do not say 30 past 90. Please instead say 60 until 180. We want it next to the x-axis. For 400, 400 is more than one full circle. Begin at the positive x-axis and spiral around. How much more than one circle is it? 40. And for 350, 350 begins at the positive x-axis and falls just short of a full circle. So you don't need to be precise with the size of your angles, but try to be approximate with them, kind of thinking about how big a 60 degree would be. 45 is halfway, so I made that 40 pretty much in the middle. You know, try to be approximate, but you definitely don't need to measure and be precise. That's one of the reasons why we put that value in there. If we did not give as many details in our graph, so I just gave you an angle that says this is 40, you would not know whether I had intended it to in fact just be 40, or whether I had intended to go around and have it be 400, or whether I had intended to go around backwards and have it be negative 320. These angles are what are called coterminal angles with each other. They are angles that end in the same location. How many times will that happen in the circle? Once per circle, right? There's only one of those lines in the circle. How big is a circle in degrees? 360. So when we're looking for coterminal angles, we're going to add and subtract a circle, or add and subtract 360 degrees. Negative 60, I'm going to add 360 degrees, add one circle to that measurement, and that gives me 300. A positive angle. For a negative coterminal angle, for a negative coterminal angle, I'm going to subtract 360 degrees. So if I would graph negative 60, 300, and negative 420, they would all end in exactly the same place. And that's what it means to be coterminal. That when you graph the angles, they will end in exactly the same place. Coterminal, co means with or together. Terminal means ending. So they are angles that end together or with each other. So if you would graph them, they should end in the same place. You do not need to graph the angles to find the coterminal angles. To find a coterminal angle, you only need to add and subtract the circle, which is 360 degrees. For the second one. The second one is more than one full circle. So we could begin by adding 360. That would be fine. That would be a completely valid answer. But if I subtract 360, I still get a positive solution. So if I need a negative solution, I need to subtract again, which leaves me at negative 225. So you will always need one positive and one negative answer. So add or subtract as many times as necessary until you have one positive and one negative answer to the question. You could, theoretically, add 12 360s if you wanted to, and it would be a completely valid answer. I'm going to ask that you don't do that, because when I read the answers for the homework, I'm going to give the closest correct answers. But adding any multiple of 360 or subtracting any multiple of 360 is a correct answer. Okay. Go ahead and try the next two. For negative negative 100. If I add 360, I get positive 260, so it'd be a positive answer. If I subtract 360, so that would be my negative solution. For 575, larger than one circle, I'm going to and subtract again. A negative solution. You could have started by adding a 360 to 575, and that would be a correct positive solution as well. But you still need a negative solution, so you would still have to subtract your way down to the 145. Negative 145. Is it 55? No, it's 45.
I don't know how I got that.
And now we need to talk about radians. A radian is a different way to measure angles. So we have talked about measuring angles in degrees, saying 360 degrees in a circle or 180 degrees in a triangle, a right angle being 90 degrees. But we have another way of measuring angles. Just like with length, we could use inches or meters or centimeters or miles. Multiple ways to measure length. We have a couple ways to measure angles. So we could use degrees, or we could use what is called a radian. What does radian sound like? Radius. So a radian is based on the idea of a circle with a radius value of 1. And a radian is created by taking an angle and kind of thinking this as a hinge and sweeping out an angle. And a radian is a measurement of the edge of the circle that is traced out when we do that. What do we call the edge of a circle? An arc, or as a whole, we call it the circumference. And what is the equation for circumference? What's the equation for circumference?
Pi times diameter.
Okay. So, listen up. If I have a radius of 1, that means if I traced out the entire circle, I would trace out 2 pi. Has 2 pi radians. 360 degrees. So if these are both talking about a full circle, they should be equivalent to each other, just as is equivalent to 1 foot. 2 pi radians is equivalent to 360 degrees. But since both of those values are even, when we work with making a conversion, we reduce down and use that pi radians is equal to 180 degrees. So just like we say 12 inches is 1 foot, or 5,280 feet is 1 mile, we can say pi radians is the same thing as 180 degrees. And we're going to convert. When we convert, for part A, the first question, 110 degrees, we want to turn that into radians. I begin by writing it as a fraction if it is not already, so I write it over 1. And then I want to multiply it by our equivalence ratio. The way I decide which way to set it up is based on what I'm given. I want to cancel. So I'm going to put 180 degrees on the bottom to cancel with the degrees that's on the top. And then the other part would be pi. We're always using 180 degrees. Multiply across the fraction and give your answer as a reduced fraction with pi still in it. No decimals, but reduce that fraction, leaving pi in it.
But what if you get a 0 as one of the answers? Would that be a negative or positive?
0 is not negative or positive.
It's not, right? 0 would be the answer.
An answer can be 0. It just wouldn't be negative or positive. It would just be 0. Negative pi over 9 is already a fraction, so I don't need to make it a fraction. So I'm going to multiply it by our equivalence ratio, putting pi on the bottom so that what I'm given cancels, which puts 180 degrees on the top. Multiplying across, that gives me negative 180 over 9, which is negative 20 degrees. Okay, so we always use 180 and pi. We set it up so that what we are given will cancel, leaving the new unit. Go ahead and try the last two examples.
What was the answer to that one?
Negative 20. First one, I set it up as 320 degrees over 1, making it a fraction. Put what I'm given on the bottom, so 180 degrees goes on the bottom, which puts pi on the top. Cancel the degrees, gives 320 pi over 180, and reduce that fraction down to 16 pi over 9. For the second one, it is already a fraction, so I don't need to make it into a fraction. Put what we are given on the bottom to cancel, which puts the 180 on the top. Multiply across the top and then divide by 12 gives negative 75 degrees.
Whoa, that fast. You did that in your head?
I did not do that in my head.
But you've done it so many times. That is good.
That is correct. I would like to think about coterminal angles one more time. So when we talked about coterminal angles, how did we say we calculated coterminal angles?
You add or subtract 360.
Add or subtract 360 degrees, because the examples I gave you were in degrees. If you have a question that is in radians, what do you think we would add and subtract?
2 radians.
Close.
I mean, yeah.
What is equivalent to 360 degrees? 2 pi radians. Listen up. So if you are given an angle in radians and asked to find coterminal angles, instead of adding and subtracting 360, since that's degrees, you would add and subtract 2 pi radians. Now, for example, let's say I was given 3 pi over 5. I want to add and subtract 2 pi to that, but what do I need to be able to add and subtract fractions?
This would be 10 pi over 5.
I need a common denominator, so I need to write it as 10 pi over 5. We're going to add and subtract 2 pi, but we need common denominators to add and subtract fractions. So I'd get 13 pi over 5 and negative 7 pi over 5. Okay? So we are adding and subtracting a full circle, which in radians is 2 pi, but we need a common denominator.